Hi everyone, welcome to the investigation of the stoichiometry of the reaction of a metal and hydrochloric acid. First thing I'm going to do is go over with you how to create the water reservoir, which is going to be the main function of this lab. This is going to be how we are going to get a crucial piece of our data to use the ideal gas law to calculate our stoichiometries here. So the first thing we're going to do is we have to assemble the apparatus that we show in the laboratory. So what we're going to be doing is using a 1 liter Florence flask. We're going to be using a sidearm flask, which I know you guys are very familiar with because we've been using them all semester. So I'm going to go ahead and get this clamped. This is going to be our reaction flask. So this is going to be where we're pipetting our 25 milliliters of our standardized hydrochloric acid and then putting in our metal to then react. As we know, that reaction will involve hydrogen gas. The hydrogen gas will then displace the water in this reservoir. And this is done like so. So I put my tubing set up here. So I got one tube that hits and it's for the head space. So this is going to be for any gas that's involved during this reaction. It'll flow through the sidearm flask and it will displace water into a 250 milliliter beaker. We'll be pre-weighing our beakers in order to do this so we can get the mass of the water that's displaced. Figure out the mass of the water that's displaced. By looking at density, we can figure out the volume in which the water that was displaced. The volume of water will be equal to that of the hydrogen gas, which is pretty nifty. So, what we're going to do now is we are going to set this up so we can purge this system completely of air bubbles. So what I'm going to do is grab some distilled water. And I'm going to fill up this beaker with some so I can see that I've purged all of the air out. So when we start the reaction, we have our 25 milliliters of hydrochloric acid in our metal. We're going to be putting in a thermometer because, as we know, with the equation we'll be using, temperature is crucial for taking all this into account. So this is just a regular thermometer plugged in a single hole stopper for the top there. But what I want to do is now purge my system so that there are no air bubbles in this line here. And why is that important? It's important because if I have air throughout this line anywhere, it's going to be quite problematic because then we won't have an accurate reading of the gas. Oh, there we go. That would be displaced. So this is really important to do, and it's important to purge this a whole bunch of times. And you can see here, I get a nice system going because every time I squeeze it, I'm seeing all that move and fluctuate. So that's really good. We like to see that. Good. So as per the directions, I'm going to do this, which now has ensured that I've purged my entire system. I'm then going to clamp this right here so that when I start the reaction, I can unclamp, stick my thermometer in, and then allow everything to be displaced. So that is the setup for this lab. Now I'm going to move on to the experimental.